Uh, Today we have a set chapter. We will cover all concepts of this set. We will go in depth to bring this lecture. There are a lot of concepts, a lot of topics that will be covered with you. As you can see in front of you, there is a word written which is nothing but only set. Yes, it is going to be our discussion. We will talk in details about it. And I am serious today. We will do something unique. Now I want to start because I don't like to waste time. So here I am starting with the meaning of set. What should be meaning of this word from your side in your language? In your language, what should be meaning of this? Most of you would say set. It can be anything. Most of you would answer something else. Now let me explain it. It is nothing but it contains a lot of things. It can contain elements, it can contain objects, it can contain members. Anything. There would be a group of something, and that group of something, this whole will be a set. Now with example, I want to explain this set with example. For example, in a basket, as we know that in a one basket we can keep a lot of things in a basket, and it's up to you what do you want to keep inside this basket. If I ask you, then you would say, okay, I'm going to market, then I will purchase vegetables. There would be potato, tomato, a lot of vegetables. So these vegetables are nothing but elements, objects. You can consider these vegetables as elements in the language of mathematics. Yeah. So remember, we have two things right now. First, we have basket, which is nothing but it is containing all elements, all vegetables. So in this basket is nothing but this is a set. Basket is nothing but this is a set, and this was containing what? Vegetables, a lot of vegetables. It can contain more things. It can contain anything, not only vegetables. Same here in this set, it will be containing a lot of things. It cannot have anything. It will have something. Did you ever notice that a basket sometimes has nothing elements? Yes, you have noticed. Same in set, we will see that a set has nothing. Okay, and this is the type of a set. We will say it later, don't worry. Right now we are understanding what is a set. So it is nothing but it has the ability to keep a lot of things, isn't it? Now Here I was saying vegetables in this. These are vegetables which are in basket, in one basket. So this vegetables is nothing but number of objects. We can consider it as a number of elements. Same here, this in this set. What is a vegetable in this set? It is nothing but elements, group of something, collection of objects, group of members. Now, are you crystal clear till now? That yes, that is a basket and it can contain objects, a group of something, collection of objects. Okay. Sometimes it would not have anything, sometimes, and we will say that set. So exact meaning of this would be what? And remember, we represent this set just by brackets, and bracket is nothing but a curly bracket. Curly bracket. Curly bracket looks like that. This is curly bracket, and we use this. It is used. This curly bracket is used to represent the set. In this curly bracket, we will put objects, elements here. This open curly brackets. I am going to take some objects so that we can understand what is a set. Here, let's take 1, 2, 3, 4. Okay, repeat here. Then I am closing it. This is a complete meaning of a set. Tell here, this is meaning of a set. But now let's break down again so that we can have clarity regarding this. Here you can see one thing more I would like to introduce to you here over here is that what this is a set. We are saying this is a set. Here name of set, we can name a set, but remember letter should be capital and element should be small. Okay, these are rules you can see. These are rules by this chapter. Now here we are naming this set. For example, A. What is the meaning of this A over here? It is nothing but name of this set is A. Name of this is what? Name of a set is A. Remember, A is a capital, not a small. And name of a set is represented by capital letter or capital, not a small letter. Are you able to say this text? Okay. Here you can replace this by any letter. For example, you can put here S, you can put here Z, anything. It's up to you. You can say it's a choice. But one thing you will have to remember is that you are naming a set, then if you are using a letter, then letter should be capital. That's it. Clear? You have understood that yes, A is nothing but it is the name of a set. Clear? Now let's break down this. We used this curly brackets. Why? Isn't it? You would say, yeah, it is used to represent set. Yeah, you are correct. I have taught you. And this curly brackets is used by, we use this curly bracket so that we can put elements inside this, and this is a right way. And inside this is what? Inside this is nothing but elements. We consider this elements. We are saying that this is element, this is element, this is element, this is element. But we know that name of this element is 1, name of this element is 4, name of this element is 2. We know that, we know name of element. But if you don't know, then you can call it as a elements, number of elements. This 1 element, 2 element, there are 4 elements, like that you can call it. Okay? You can call it. This was about set. Now try to understand. In this set, we have one set. We have one set. And one set is nothing but this. Now tell me, in this set, how number of elements are how much? In this element, in this set, how much number of elements are there in this bracket? You can easily count. You would say 4, there are 4 elements. Yes, you are correct. When question is asking, tell me what are number of elements in this set, then you would count them. You would answer that yes, these are numbers of elements. There are 4 elements in this. And you know that right now we have one set. We can have a lot of set. For example, I am going to create another. Let's say C. Can you not say that it is a set? Of course you would say, because all rules are being applied here. We have name of a set, we have number of elements which are in bracket, curly brackets, and this is what is your set. But right now we have 2 sets. First is this and second is this, and both are different. Name of a first set is A and name of a second set is a C. In one set we have 4 elements, and in second set we have also 4 elements. But elements are different in both. So here we are observing that both are different. We know that both are a set, but we cannot say that both would be same. No. Okay, I think we should move ahead of it. Ahead of it. Now. Here, this would be 1, this is 2, this is 3, this is 4, this 5. Right now we have how much? In this we have 5 elements, and in this we have 4 elements. Number of elements. What if I want to ask you that where is E? Where is E? What is the position of E in the second set? Then you would say at the second and second. Like that you will answer. When question will ask you that what are number of elements of second set, then you would say number of elements in a second set are nothing but 5. And now it is very easy. I know. Just have a look for a few seconds. Now let's make a setup by a given equation. Here a set of collection of natural numbers. A set of a collection of natural numbers. We know that this is not a set. It is a set but indirectly. This is a statement. We have to convert this statement into mathematics, into set. How to convert? It is very simple. Look at here. It is already saying we have a set, and in a set we have a collection of a natural number. But it is an infinite. We know that natural number starts from 1, not from 0. Here we will start from 1. Here we have a set, okay. Then open curly brackets, natural number. So 1, 2, 3, 4, 5. This dot will represent that it is a infinite number. Then we will close it. This is a complete conservation of this statement. We have converted this into this. We can see. Now we can confidently say that yes, this is a state. This is a set. And you are able to read this. That yes, in a set there are a lot of natural numbers. Why natural numbers? Because it is starting from 1, not a 0. Not a 0. Now here next we have a set which name is Z, which name is X, okay, which name is X, is a collection of whole numbers. Now what would we say of this? Same but different. Little different, not more different. Here we have given name of a set which is X. In this set, not the natural, whole number. And we know that it starts from 0. It starts from 0. And this dot is representing about the infinity. Then we will close it. It is an infinity. We can limit this. But how? Just by saying that yes, that it is starting from 0 and then 5. Like that we can give additional information so that we can stop a natural number. Now it is telling you that It is telling you that we will start from 0, but we will end it before the 5. Before the 5. That is how a number is ended, just by using greater than, less than uh, sign. Here we used a square sign. Why? Because it tells that we will start with this given number, and when we use this round circle, round bracket, then here we are saying that we will stop before this 5. So before this 5 would be what? 4. 4. Okay, that is how a lot of things are stopped. Now let's move. Next we have L, and then row Z, then Z plus, I think Q plus R. Yes, right now all this. What is the meaning of all this? I wrote N, W, this, that, this. What is the meaning of this? N represents natural number. It is nothing but, N is nothing but natural number. And this word, this is what? Integers number. But here we added this addition, so it will become positive integer, not negative. We are avoiding here negative, but in this we are taking all negative, positive, 0, 1. Here Q is here, we are presenting a rational number as a Q, so this is a rational number. Now next we have Q plus, it means all positive rational number. Okay. Next we have here, this R means real number. All this will help in making set. If in a set we are writing n, it means this is a capital, not a small n. A small n will represent number of something, but here we are representing this n for natural number. So whenever in a set w will come, then we will be understanding as w is nothing but it is a whole number. Okay. The next we have z. It is representing about the integer numbers. Next we have z plus. So here we are taking what? Positive integer numbers, because here we added positive. That's it. If here is a negative, then here we are saying that here integers are negative. Okay. Next we have q, which means rational. We will take all negative rational, all positive rational, and next we have q plus. It means all positive rational. Then ahead of it we have what? Last, which is a real. Real number takes what? A rational or irrational number. Okay. So all this is saying that in a set, rational real number can come, rational can come, integer can come, positive integer can come. Okay. All this will come. Whenever, but remember, this whole word will not come. this just letters will come. Then we will have to understand yes meaning of this is something. Okay. With example, would you like to understand about this? Here we are saying a dinner x is a all natural numbers. That is what we are saying. X is a all natural numbers. Here x we are taking as a elements. X we are considering as elements. But here rather than taking in natural number, we can write only, we can apply only n. Okay. You will be able to understand what is the meaning of an n. I will be able to understand. So rather than taking word, we can represent any of them by just letter. Now this is telling you that x is all natural numbers. X is what? Elements, and we will start from 1. Here can be what? Here can be z. It means integer number. In a set we have integer number. What if we apply here this positive? It means only positive. You know that positive, when integer becomes positive, it means we are taking natural. No natural. We are taking whole number. Okay. Whole number is equal to positive integer. Let's replace this by r. Here meaning of this is what? Meaning of this is that we are putting in a set which are nothing but real numbers, which can be rational or irrational. Okay, something else. X such that it should start from 0, not 0, no 2, then greater than x, then 7. Here we have this. What is the meaning of this? What is the meaning of this? It is nothing but this is in a set builder form. This is in a set builder form. It is in a set builder form. How to identify a set builder form? Just look at here. What is happening over here? Here we can see this is not readable. It is not telling clear to us. Yes. If this is happening, it means you have a statement which is in set builder form. You have a set which is in set builder form. In that case, you will not be able to understand directly, but you will have to understand indirectly. And that is what is the meaning of a set builder form. Okay. Now let's understand. We will see. We have seen what is a set builder form. Now, roster form. We have two types of form. First is a roster form. Second we have set builder form. So this is a set builder form. So what about the roster form? You would say, what about the roster form? Okay, don't worry, it is coming over here. Now we are going to convert it into roster form. We are going to convert this into roster form. How to convert it into this form? Before this, let's try to understand this. What is it saying? What is it saying? It is explaining that you will start. You have already a set. You have already a set which name is A, and you will have to start from 3. Because x should be greater than 2. Here 2 is a less than 3. So we will start from 3 because here it is the same. 3. Okay. Then it will be continuing, but we will stop where? Till this 7. We will take this 7. Here it is telling you that this sign. It is telling you that it would be equal to 7, which means we will stop till this 7. Start from 3 and end till the 7. And these are elements of a set. This was meaning of this set. Now we are going to convert this into roster. This is very easy. A would be as it. Just take curly brackets. We know that we have to start from 3. Then it is a continue 4, 5, 6, 7. It is telling you that end at 7. Now this is a complete. What's the difference? This and this, between this and this. It is in set builder form. We know that this is a set, but it is in set builder form. Now this is also set, but it is in a roster form. This is nothing but it is in roster form. This set is in roster. Now let's understand what is roster form. Roster form is a set which will tell you clearly. You will be able to understand. Here you can say that yes, we are starting from 3 until 7. It is a very readable. You will not have to apply more efforts to understand this. So roster form is a very simple, and set builder form would be something complex to understand it. That is what is the difference between it. Okay. And remember, meaning of this and this is same. Meaning of this both is the same. Both are not different. Just form are different. It is another form. This is another form. Just form are different, but meaning are same. Okay. So we have understood meaning of a set. We saw how to convert it. We saw meaning of a set builder form, then roster form. How to convert a set builder form into into roster form. Now here, if you are given this a set which is in roster form, and question is asking that convert this roster set into set builder form, then just like that you will convert. Just opposite of it. Just opposite of this. So one question I would like to give here over. After this, we will understand types of a set. Learn. Look at here. This is set, which is in a register form. Now question is asking convert this into set vector. What will you do? Just we know that yes, y as it is the name of a set. Now x, which means this element, is such that it should start from 17. From 17. And x, then it should end at 66. Now hold on. This is not well defined. 27, 28, 29, 80. It should end at 80. That's it. We have converted this roster from this object set into set builder. That is how you will do. Now let's see what is this. It is nothing but belongs to. Meaning of this is what? Belongs to. Just like that here. We can easily say that 28 belongs to Y set. Can we say? I am talking about this. Each elements of a set Y belongs to this set. Here we are saying this element is belonging to this set. If we have two or more sets, then it will be useful. It will help us. For example, here A is what? 1, 2, 3, 4. Okay. Right now we have two sets. And this is telling me that 28 is belonging to Y set, not A set. If 82, now here I am saying 82 is belonging to Y, but we can say that in set Y there is no 82 elements in this. In that case, we are saying that 82 does not belong to Y, and that is how we will explain that a element which is not belonging to this type of a set. Just this is slash over belongs for a sign. Okay. Now here 4. It is belonging to in which set? 4 is belonging to in which set? You would say it is belonging to this is set A. So it belongs to A. This is what is the meaning of this sign. It is not A, it is a belongs to. It is a sign which explains that something is belonging to something. Okay. Now I am saying that 5 here. 5. Okay. Y and 5 A. What would you like to say about this? Here I am saying 5 is not belonging to Y, which is true. Here we can see there is no 5 in this set. So that's why here slash you can see it is mentioned here. It is applied. This slash, this sign is telling you that 5 is not belonging to y. Same here, 5 is not in set A. That is what is the meaning of this sign. Clear? Now we are able to move ahead. Types of a set. Types of a set. Types of a set. Let's start from empty set. From empty set. Empty set. Do you know meaning of empty? Do you know meaning of empty? I'm talking about this one. We have understood about sets. Now I am not going to explain this set. Just I am explaining types of a set. First type of set is a empty. Empty, which means nothing. There are no elements in a set. For example, y and this. Here in this set we have no elements, nothing. This is still set, but in this there are no elements. So this type of this kind of a set is nothing but empty set, and empty, which means there should not be elements. There should not be elements. Now what's the difference? This 2, 3, 4, 2, 4, 6. What's the difference between this and this? In this set, in set Y, we don't have element, but in set X we have elements. So this set which does not have any element will be nothing but empty set. Now next, and it can also be represented by 5. It can also be represented by 5. It is also called as a null set. Null set. Clear? Null set. Null set, which means no elements in a set. Now next, singleton set. Singleton set. Singleton set. This is the second type of a set. What do you mean by this singleton set? This is a set which has only one element. It's called singleton set. It is a very simple definition about this singleton set. A set which has only one, not more than one. Only one. Only one elements. For example, here we can understand it by this set. Here in X set we have only one element, which is 2. So this is giving you one element, and a set is giving you one element will be a singleton set. Here you can see there is a word which is a single, which means one. Yeah, that's it. Okay. Now next would be I think it should be infinite finite set. Infinite finite set. Finite set. then infinite set. I will take all those types of a set, don't worry. One by one we will understand. So let's explain this finite set. Finite which means a limited limit. We have limit of elements. Just understand meaning of this word which is given to you. Finite. Finite is equal to limit. Number of elements are limit, is limit, will be infinite set. In a set there are limits which is there are elements which are limit, will be finite set. For example, in this it is a limit. But with the other example we can understand about this, don't worry. A. Then here we are saying 1 by 2, 1 by 3, 1 by 4, 1 by 5, and that's it. And next we have 1 by 2, 1 by 3, 1 by 4, 1 by 5, and this row. What's the difference between this A and B set? What's the difference? What would you like to say in this case? Here, this set A is giving you a limit of numbers of elements. Here we can see number of elements are how much? 1, 2, 3, 4. 4 elements. We can count these elements. But in this set, we have also 4, but this dot is telling that it is keep going on. How to read it? 1 by 2, 1 by 3, 1 by 4, 1 by 5, and so on. And so on. It is infinite. There is no end of this ration number. And it is ending. There will be 1 upon 5. So this ending will be nothing but finite set. And there is no ending in this case, so this would be infinite set. This is set. A set has infinite number of elements. We are calling it as a infinite set. Clear? So we are crystal clear about these 4 types of a set. Okay. Now let's move ahead of this. Next, we would like to take I think a subset. This is very important because it will help to understand a relation function. But we will take we have a separate lecture about relation chapter, about function chapter. First of all, let's complete this set chapter. So here is the subset. Next type is a subset set. Subset. Here it is a piece. It is a part of a set. We have again set which is a part of another set, and this is what is a subset. Are you understanding to my point? What I am saying? Here you can see I am saying that I hope you are crystal clear about this. Okay, I am going to erase it so that I can explain about a subset set. Here, let me erase it. Look at here. Subset. We are talking about this. This is subset set is nothing but it is a part. It is a part of another set. It is a part of a set. With an example, let's try to understand. In this we have 4 elements, okay? Yeah, you know. I am saying that B is nothing but it is a subset of this set. Can you say yes? If all the elements of a set is in other set will be subset. For example, here this B set has two elements which are part of this set. You can see we have two this and these are in this also. So in this we have four elements, but in this we have two elements, which is nothing but it is a part of this set. That's why we are calling this as a subset of this. We are saying that B is nothing but B set is a subset of set A. Set A. That is how we read this. B is a this set is a subset of a set A. Clear? Just understand it very simple that yeah, this will form another set which will be a part of the first set. This first. Okay? Clear? Now what about superset? I think so. Superset. Superset. It is nothing but just opposite of this. We are saying that A is a superset of a B and B is a subset of A. Just opposite. Just opposite. Okay? Now next. Next, what else? Just have a look. Yeah, right now I have this much types of set. This much. Now, what else? Empathy. We have understood empathy, singleton, finite, infinite, subset, and superset. Okay, superset. Let's try to understand ordered pair. Ordered pair. Do you know what is ordered pair? Ordered pair will come from subset. Don't worry. So let's understand the ordered pair. Okay, ordered pair of something. That is a clear. This is it. We are going to understand the ordered pair. Ordered pair. This ordered pair is a coordinate of two elements. Let's break down it. This is nothing but it contains two elements. And just we write these two elements in inside the round bracket just by separating comma, by using comma. For example, we said here there should be two elements. Okay, inside the round bracket. This one 2, 4. Okay, 2, 4. This is just an example. Now we will surround it just by using close round bracket. Now this whole is a ordered pair. This whole is a nothing but this is a ordered pair. We can say in this we have two elements which is separated by this comma. Okay, and this two elements is inside the bracket, and this bracket is nothing but a round bracket. and this is what would be our ordered pair. Elements can be anything, but number of elements should be 2, not 3, no, not 4, not 1, only 2. Only 2. Okay. So this was about the order pair. We will link this with another discussion. Don't worry. Now, do you know set operators? Set operators. As we know, operators of mathematics, which are basic, for example, addition, subtraction, division, multiplication, all these are basic operators of mathematics. Similar here, we are talking about the set operators. So these set operators are nothing but union. I think this word can be union. Next, intersection. Then universal. What else? Let's try to understand this union, intersection operator, universal operator. Let's try to understand. Here, first of all, let's see what is the universal. This is a big set, and it can contain 2 or more set. I am saying 2 or more set, not only elements. This is the biggest set which will be containing 2 or more set. And apart from this set, it can have more elements. Okay, it can have more elements. And this is what we call it as universal set. Universal which means big. But in a big, there are number of sets. And apart from this number of sets, there can be elements, more elements. For example, for instance, with the help of a Venn diagram, we can understand it. Here, this is nothing but universal, and universal we represent it just by drawing a rectangle. This whole rectangle is a universal, and in this whole rectangle we can take two set. And this set is nothing but it is A and this is B. It can be X, it can be Y. It's your choice. So this set has what? Let's say 2, 5, and this is 27, 28, 29. These are elements of this set A. These are elements of this set B. But try to understand. We are visualizing it. This is a universal set. This wall is a universal set. Okay, this wall is universal set. This whole universal set is containing these two sets. And apart from this set, in this can come elements. It's your choice. You can here, for example, 99, 100, 6, 7, 8, like that. We can also enter more elements in universal. So all these elements is nothing but it is a set which is a universal set. Do you know that set is a unique? It contains unique elements. In a set, there cannot be repeated elements. For example, here we have 27, 28, 29. Again 27. This is wrong. This representation of a set is wrong because 77 is coming 2 times, which is not valid for set. So that's why it is said that this should be unique. elements should be unique. One element should come one times, not again and again. Okay, so this 77 will be avoided. Okay. Now here, so I hope you have understood about the universal set. Let's try to understand this union. But hold on, we understood this universal set just by this Venn diagram. We can also understand this just by this set A. Then we have in set we have 2 5. We have 2 5. We can say that universal of these two sets would be nothing but it will form another set, and in this would be what? Unique elements, and all these elements will be included in this universal set. 77, 28, 29, 2, 5, and we can enter more, which is nothing but this 6, 8, 199. Here you can see this universal is making another set, isn't it? We had already these two sets, and universal of these two sets would be this. And in this universal set we can enter more elements. It's your choice. So this was about the universal set. Universal set can contain 3, 4, 5 sets. Okay. Now let's try to understand union. This union is like a addition. It is like a addition. With the help of this set, we can understand about the unit vector. Here, remember, union will not take a common thing. Common, which means we take 2 or more. We should have 2 or more sets, and then we can understand about the union and about the intersection. So right now we have 2 or more sets. Union tells you that I will not take a common thing. For example, here in this we have 2, 5, 79. 2, 5, 79. So union of these two sets would be what? Just a union is represented by this symbol, and then we are saying union of A and B would be what? We will just avoid repeating elements which will be coming. For example, 77 one times, 78 one times, 79 one time, then 2 and 5. Here 29 is coming again. So 79 is already mentioned. So that's why this is so common we will avoid. Just we will write it once time. This is what is the definition of a union operator. Yeah, we know that this is an operator. Remember, whenever it is coming, what union is coming, then here you are understanding, yes, we will avoid common elements. We are going to avoid common elements. Same just opposite of this is nothing but this is intersection. Union is just opposite of intersection, and intersection is just opposite of a union. You have understood what is union, but you didn't understand what is a intersection. It's a time to understand about intersection. So it is said that it explains that I will take common elements. Who is saying? And section is saying that I will take only common elements. And in this two sets we have what? So remember, subset is represented by this symbol, Union will be represented by this symbol and intersection will be represented by this symbol. This is a subset and this is what? This is a union and this would be intersection. We have seen subset and intersection. Right now we are on intersection. Okay, we have seen subset and union, not the intersection. So what would be intersection of A and B? So intersection of A and B, would be what? Here we are saying what are common elements in these two sets. So in these two sets, this 5 is not common. It is coming one time. 79 is coming two time. That's why we will write it one time. So 79, and it would be in another set. This intersection will create another set which will contain a common elements of two sets. This was about what? This is about intersection. Okay, just to understand it, union nothing common, intersection only common, and universal all elements of all sets. Here subset will be represented by this symbol, and union will be represented by just a u letter, and intersection, remember this is not a u letter, this is a sign operator. Intersection will look like this. So all these are except this subset, all these are this intersection, union, universal, all these are operators, set operators of a set. Now let's just, this is a clear, it is done. Now let's see this a minus b. Here we are subtracting a subset a set from b set. Let's visualize it. I hope today here you are clear. Okay, let me erase it. Okay, here A difference B. A set has a 2, 5, 6, 7, and B now. Right now we have this two sets. Okay, in this we have 2, 5, 6, 7. In this we have 7, 5, 11, 12, 15. Now here it is saying A is nothing but it is a set because this is a capital letter. That's all. Okay. So A minus B. Here we are going to subtract a set from B. So here A set. So whatever will be common in both, we will avoid this, and just whatever will be left in this, we will write over here, and it will create another set. So in this you can see 2 is not in this, 5 is not in this, 6 is not in this, only 7. So let's say this 5 and 7. So 5 is in this, 5 and 7. So 5 and 7 we will avoid it. Okay, and whatever we left in this set A, we will add just this. For example, 2 and 7, no, 6. So this is another set of this difference. Here difference B. What did you understand? You understand? You understood that we subtracted this common things from A from B. Now B minus A, it is just opposite of this, B minus A. Here we are going to subtract B set from A. We are going to subtract B set from A. Now what will happen? We will start from here. So here in this 7 5 and 7 5, this common we will avoid, and whatever will left in this B will be written over here. Will be written over here. So here we have 11 12 15. 11 12 15. That is how we do difference between two sets. You can see. Okay, let me repeat. Here we subtracted this A from B, and in this we subtracted this B from A. Just opposite. Just opposite. Clear?